Hi, my name is Jace Harwood. I am a process engineer at Fotofab located in Chicago, Illinois. So in the name Fotofab, what it means is that we take a photo technology that was used from Kodak and we put it onto cleaned metal parts. So if you can understand this is like putting a CAD, anything you can put on a CAD drawing, we can put that onto a piece of metal and we can make it through the process called chemical etching. We can make that into an actual physical metal part. And it's pretty simple. We just take metal, we just coat it with a gel that's photoresistive. And then we translate the image. You know, if you've ever done like stencils, you can stencil any pattern that you've cut out, but we do that digitally. And we have digital stencils that we use. And we put UV light onto the gel that we coat on these panels. And what it does, the UV gel hardens this gel. And so the hardened part is like usually an inverse image. And then we wash away the part that was that didn't get contacted with UV light. So that allows us to do the actual chemical etching part. Chemical etching is just applying acid sprays onto the surface. And the sprays that contact the metal, they dissolve the metal very quickly because we do it at high temperatures and high pressures. And then after that comes out of a conveyorized machine, it is the part that the customer is desiring to have. So what we do next is we have to remove that hardened gel off of the metal parts. So we put that into another chemical process called stripping agent and send it to inspection. And then that inspected part gets sent to the customers. So why is a chemical engineer needed for this kind of stuff? And what basically is my role as a chemical engineer? A chemical engineer is very important to many different production processes. My specialty is obviously in chemicals because that provides more in-depth knowledge of how to do this process safely. A lot of the times chemicals react with their environment, they turn into gases, they act in a different way, they turn into solids, they act in a different way. So I have that knowledge that other people don't have, and I have the background with the other engineering fields so that I understand like the different mathematics that are involved for like any kind of physical process basically, and the machinery that is used to make processes. Chemical engineers specialize in mixing different chemicals and pushing them through pipes. So just a glorified plumber sometimes. My educational background is that I pretty much knew my path going into chemical engineering before I entered college. I did well in the chemistry classes that I took in high school. Did well in the math, and then I knew some people that I talked to about chemical engineering, and they led me pretty much right into that field out of college. Once I got into college, the basic level classes don't really give you a feel for what chemical engineering is about, but you will be taking like the different chemistry classes that the college offers: inorganic chemistry, organic chemistry, physical chemistry, and the different math classes, which are the different calculus classes, which are 4 of them typically, and thermodynamics. So I also took a route where I took computer classes. And the reason I did this is because I found it very useful because a lot of the projects that I do involve disseminating large amounts of data. So I got to take large databases and I got to make them talk to each other. And, those things can later be put into automated processes, which open and close valves or open and close for heat controllers, kind of like for different applications. Some facts about chemical engineering is a lot of the stuff that you do is potentially explosive. I have worked with a chemical called ethylene oxide. And ethylene oxide is an extremely unstable molecule in then it readily turns into a vapor. And so even just a little bit of static electricity could detonate a large tank, which people would feel the detonation like that from miles away. But we can do this process because of engineering. We can do it in a safe manner. And as long as all those systems are in place to take the energy away, to make it non-static, to ground it, to make sure all your pipes are grounded, and then make sure all the special safety factors are built into your process at the reactor itself, then you can make this without harming anybody, without your reaction running away, and you can make some really useful products. A lot of the stuff that I made with ethylene oxide as an engineer are found right on the back of your typical shampoo or conditioner bottle. We made those for different larger companies like Procter & Gamble. So the other thing is, that was pretty interesting too, is something called monochloroacetic acid, which is, if you get just an amount on your palm, like a couple drops on your body, it could be potentially fatal. So you have a big storage tank and you have to take it to a big reactor on the other side of the road where people are walking under it all the time. You can't have a leak. It's extremely, dangerous, like I said. But we do this all the time. There's engineering safeguards that we put in place so that if a leak ever does occur, then we have visual cues that we can see, so that it can be corrected immediately. And that product goes into a certain formulation that when you have your infant child in a bathtub and the soap is put on the child's hair and the suds gets in the child's eye, that monochloroacetic acid, after it's been fully reacted with different oils, is what makes it so that the eye doesn't get irritated for infants and for children. So it's, you have to have a healthy respect for everything that you do. And it's through chemical engineers that formulate this process and make sure that it's safe and make sure that the testing is done from start to finish, so that everything can be safely and efficiently done. So a lot of the things, there's different niches that you can go into that explain, or that this field has basically limitless opportunities for development. The development field that I chose is something called continuous improvement, and it's a way that you can really define an issue that a company has. So you're an investigator basically, and that's one of the things that kind of drew me to this field too, is that I built the skill set so that I can go and examine a problem and scope out the solution. And this is really important, because if you don't have a good scope, if you don't have a good line of sight on what it's worth or how you're going to do it, then the opportunity to fail or the opportunity to not get to your endpoint is it becomes more difficult. So through continuous improvement, I learned a very systematic and rigorous way that I can prove to other people that this is what we need to do, and this is how much savings it's going to give us for return on investment. And then using different data analysis techniques, for instance, that I use at Fotofab, I can go and see that the slight changes that we make in our process, what the end result will be, and takes all the guesswork out of it, and really allows you to step through and test different hypotheses, as a basis as a scientist. We make products for a lot of different customers, such as aerospace, healthcare, electronics, and automotive. So I just wanted to conclude it by giving you some resources that I have used in the past. Something to keep me might help you guys to understand a little bit more about chemical engineering. First is the American Institute of Chemical Engineers, AICHE, and the other one is the American Chemical Society, ACS. And if you want to learn more about Fotofab, it's obviously www.fotofab.com. And you can find us on LinkedIn, Facebook, and Instagram. I thank you for watching this, and best luck.